Today's lesson is about understanding addition of integers and other rational numbers. As always, we're going to start our day with a problem of the day. There are 4 questions on this slide for you to answer. You're going to pause me, work on those, and then come back when you're ready to check. All right, the additive inverse of 5. Additive inverse means the opposite. When we first learned this, we found that on a number line, the additive inverse was the same distance from 0, simply on the other side of the number line. That means the additive inverse of 5 is negative 5. Number 2, absolute value is the distance from 0. So negative 9 is 9 spaces from 0. So is positive 9. So negative 9 and positive 9 have the same absolute value. Number 3, 17 and negative 17 have the same absolute value because they are the same distance from 0. Number 4, first I have to simplify. The absolute value of negative 9 is 9 because it's 9 spaces from 0. The absolute value of 5 is 5 because it's 5 spaces from 0. And then I can start graphing. All right, so 9 goes 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. 3 belongs 1, 2, 3 right here. 5 belongs 1, 2, 3, 4, 5 right here. 0 is here, and negative 4 is here. Now I want to order them from least to greatest, and I'm going to make sure that I write it in the original format. So negative 4 is the smallest, followed by 0, 3, the absolute value of 5, and the absolute value of negative 9. All right, this is a review slide. As always, I want you to go ahead and work this while I'm paused, and then come back and check when you're ready. All right, David is playing the integer game. He has 4 cards, a negative 6, a 1, a 12, and a negative 4. And we want to know what the sum is using a model. We're going to use some vectors on a number line. 1, 2, 3, 4, 5, 6, 7. And negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 should be sufficient. All right, so our first vector is going to start at 0 and work left 6 spaces. That represents our negative 6. We're going to start where that vector ended and move to the right 1. That represents our 1. We're going to continue again where that last vector ended, but this time we're going to continue 12 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 brings us here. And our last vector will represent the negative 4. So we will start here and move back 1, 2, 3, 4. And I believe David has an answer of the sum of 3 in his hand. So David would have to somehow get a negative 3 in his hand in order to win the game. Your learning target today is I can accurately add integers and other rational numbers. All right, so we're going to use a horizontal number line to model the following expressions. We're going to use some vectors to do this. So as a review, we always start at 0. And our first vector is a negative 2. So the 2 tells us how many spaces, and the negative tells us what direction. So I'm going to start at 0 and move back 2. There's my first vector, represents negative 2. We will start where we ended to do 4. The 4 tells us how many spaces. The positive tells us which direction. So we're going to move 1, 2, 3, 4 spaces to the right. Our answer is positive 2. All right, so now we're going to try with a vertical number line to model the following: 5 plus a negative 1. You're going to practice this as I'm paused. Come back and check when you're ready. So as always, we're going to start at 0. Our first vector has to represent a 5. So 5 tells us how many spaces, and the positive tells us which direction. So I'm going to move up 1, 2, 3, 4, 5. And then our second vector, the 1 tells us how many spaces, the negative tells us which direction. So I'm going to move 1 down, and my answer is 4. All right, it's time to work with a partner. I have a horizontal number line here. I want you to model with vectors -8 plus 3 and find the answer. Pause me while you work. Come back and check when you're ready. So you start at 0, as always. To model this integer, the 8 will tell us how many spaces. The negative tells us which direction. So I'm going to move 8 spaces to the left. We're ready to start our second vector. The 3 tells us how many spaces. The positive tells us which direction. So I move to the right 1, 2, 3. My answer is -5. All right, so we've talked about how numbers don't really happen in isolation in the real world. So I have a vector diagram here for you, wanting a story problem to go with it. So you have 3 vectors. Your story problem will have to include a +9 plus a -9 plus a +5. I want you to write your story problem on a note card and hand it in for credit. On the next slide is a table showing the change in temperature from morning to afternoon for 1 week. Use a vertical number line to help you complete the table. As an example, the first row is completed for you. All right, so here we have a morning temperature of 1. We know that it rose 3 degrees. So our equation is 1 plus 3 equals 4. The afternoon temperature is 4 degrees. Would you please finish the rest of this table on your own? I should be paused. When you're ready to check, come back to me. All right, so if we start in the morning at 2 degrees and it rises 8 degrees, it will be 10 degrees Fahrenheit in the afternoon. If we start at -2 and it falls 6 degrees, it will be -8 degrees in the afternoon. If it starts at 4 degrees and it rises 7 degrees, it will be 3 degrees in the afternoon. If it is 6 degrees and it falls 9 degrees, it will be -3 degrees in the afternoon. If we start at -5 degrees and it falls 5 degrees, we will be at -10 degrees in the afternoon. If we start at 7 degrees and it falls 7 degrees, we will be at 0 degrees in the afternoon. All right, so now it's time for us to start working with other rational numbers. So you're going to work with a partner to create a horizontal number line. We're going to try and represent each of these on the number line. I'm going to give you a chance to try it on your own. Go ahead and pause me, and when you're ready, come back and we'll check. All right, as always, we're going to start at 0. 6½ tells me how many spaces I'm moving. The negative tells me which direction. So I'm going to try to be very careful here. 1, 2, 3, 4, 5, 6½ to the left. I'm going to add to that 2 1/4 more spaces to the left. So I'm going to start at 6½ and move 1 to 7½ 2 to 8½ and 1/4 would take me to -8 3/4. All right, so now we're going to try using other rational numbers again for the horizontal number line. I want you and a partner to practice this one. When you're ready, come back and check me. As always, we're going to start at 0. I'm going to try really hard to move to the right. 7 1/3. 7 and just a hair more. I know I need to move back 8 2/3, so I'm going to think this through. If I moved all the way back to 0, I would have moved 7 1/3 out of my 8 2/3. If I move one more, I have moved back 8 1/3, but I need 8 2/3, so I need just a hair more. So if I look at that carefully, I am at -1 1/3. All right, again, pause me while you practice this with your partner. When you're ready to check, come back. We're going to start at 0. My first vector will go all the way to 9. My second vector is going to move back 2 1/4. So back 1, back 2, and back a 4th. That leaves me with 6 whole and 3/4 spaces. All right, it's time for your exit ticket. Here are 5 questions for you to answer. Make sure you turn them into the folder, and then when you have time, the next slide is reminding you to play the integer game.